Today, we're talking about a revolution that's happening not on our screens, but literally in our skylines. It's all about how data, robotics, and some truly radical engineering are letting us build things that, honestly, were pure science fiction just a few years ago. We're going from digital pixels on a screen to massive concrete pillars, and it is an absolutely wild ride. So let's dive in and see how this is all happening.
I mean, really, how do you even start to build some of this stuff? How do you build a skyscraper that does a 120-degree twist to shrug off hurricane force winds? Or how about one that's built horizontally, like a 300-meter-long bridge connecting towers way up in the air? And what about a hotel that's built not up, but 88 meters down into an old quarry? And get this, these aren't just some architect's wild dreams. These buildings are real. And the way they were built, well, it's completely tearing up the old rulebook.
So, what's the secret sauce? Well, it doesn't start with hard hats and hammers, not at first anyway. It all kicks off inside a computer, in a world of pure, unadulterated data. We're talking massive, and I mean massive, streams of information that basically create the digital soul of a building long before a single piece of steel is ever put in place. All right, so let's get into our first big idea, the digital blueprint. Every single one of these incredible projects starts its life as this insanely detailed digital model. And this isn't just, a pretty 3D picture. It's what people in the biz call a single source of truth. It's basically the brain of the entire operation, coordinating everything from day one until the doors open. Okay, the magic word here is BIM, which stands for Building Information Modeling. You can think of it as the building's digital DNA. It's the one place where everyone, and I mean everyone, from the big shot architect to the person programming the welding robot, is on the exact same page. So it's got the blueprints, sure, but it's so much more. It's running simulations, like what happens if a massive earthquake hits. It's got the entire schedule down to the minute, and here's the kicker. It has the exact step-by-step instructions that get beamed directly to the robots. So, one of the key sources we're looking at breaks this whole revolution down into 4 clear steps. Think of this as our game plan. First up, digital design. That's the BIM stuff we were just talking about. Then we move to robotic manufacturing. After that, autonomous transportation. And finally, the really cool part, robotic assembly. The key thing to remember is that this is all one seamless system. It's connected from the very first click on a mouse to the very last robot tightening a bolt. Okay, so the digital plan is locked and loaded. Let's see how these pixels turn into actual pieces of a building. And that brings us to Act 2, the robotic factory. So picture a typical construction site. It's muddy, it's messy, you're at the mercy of the weather. Now, forget all that. We're moving indoors into a super clean, super controlled factory. This is where buildings are now being manufactured, piece by piece, on an assembly line, kind of like you'd build a car. This quote just nails it. The buildings of the future are manufactured, not built. It's a total mindset shift, right? Instead of dumping a pile of bricks and steel on a plot of land, you're making huge, finished sections of the building in a factory. This whole idea is called prefabrication, and let me tell you, it is a complete game changer when it comes to quality, safety, and just pure speed. And what's so cool is how they're doing it. It's not just one robot doing everything. For something like bricks, you've got these fully automated lines, or even cooler, they're 3D printing them, so you can create these crazy custom shapes on the fly, no molds needed. Then you've got timber. You've got these giant robotic arms with saws, getting their instructions straight from that digital blueprint, carving out these super complex joints with insane precision. And for the steel frames, the bones of the skyscraper, you have welding robots that can lay down a perfect weld every single time. It's a level of quality and consistency that, honestly, no human could ever match. But we're not just talking about single bricks or beams here. We're talking about entire chunks of buildings. Okay, get this. There's a factory in South Korea. It's the biggest of its kind, and it's run by 41 robots. They take the digital plans, and they don't just cut the wood, they build entire modules. We're talking whole walls with the windows already in, floors, ceilings, all the wiring, plumbing, insulation, it's all done. So a house that would normally take you months to build, they can manufacture all the main parts in just 3 days. Then they just ship it to the site and snap it together like Legos. Okay, but you've got to be wondering, right? How do you make sure all these giant pieces made in a factory miles away are actually going to fit together perfectly? Well, that's where automated quality control comes in. It's brilliant. They use these super high-tech laser scanners that create a perfect 3D map of every single part. Then, the computer automatically compares that scan to the original digital blueprint. If anything is off by even a millimeter, it gets flagged instantly. So when those parts show up on site, you know they're going to fit together perfectly. No surprises, no expensive delays.
Okay, so we've got our flawless digital plan. We've got our perfectly made parts fresh from the factory. Time for Act 3, the automated site. Now we're finally heading to the construction site. But I want you to erase the image you have in your head. This place is different. It's run by a whole new kind of workforce, a robotic one.
Man, this really lays it out, doesn't it? The old way versus the new way. Traditional construction is one of the most dangerous jobs out there. It's backbreaking, repetitive work. It's slow. A little rain can shut everything down. The automated approach just flips the script. The robots get all the dangerous, heavy lifting jobs, which makes things way, way safer for the humans. Plus, robots don't get tired. They can work around the clock in any weather. And the speed and precision they bring, it's literally superhuman. So let's meet the crew. First up, you've got Hadrian X. This thing is basically a bricklaying robot on a truck with a massive 100-foot arm. It can lay something like 500 blocks an hour and build all the walls for a house in less than a day. Insane. Then there's Sam, the semi-automatic mason. This bot can lay bricks up to 5 times faster than a human. And check out the mule. It's a lifting arm that helps a worker lift a 135-pound block like it only weighs 5 pounds. And maybe the wildest one is HRP-5P from Japan. It's a humanoid robot. It can literally grab a sheet of drywall, walk it over, and install it all by itself.
So what does this mean for the bottom line? Well, the numbers are pretty jaw-dropping. 50%. Just let that sink in. Contractors using a robot like Sam are reporting they can cut their direct labor costs in half. And that's before you even factor in how much faster they're working, how much safer it is, and how much less material gets wasted. The money side of this is just undeniable.
Now, I know what you might be thinking. Oh, great, the robots are taking all the jobs. But that's not really the story here. This is about collaboration. The whole point is to augment human skills, not replace them. Let the robots do what they're good at. The boring, repetitive, dangerous, heavy stuff. That frees up the human workers to do what we're good at. You know, the tricky problem solving, the fine detail finishing work, the quality checks, all the creative stuff a robot just can't do. It's about humans providing the brains and robots providing the brawn. And that brings us to the grand finale, the payoff. We've seen the plan, we've seen the factory, we've seen the robots on site. Now, let's see what they can actually build. This is where all those digital pixels finally become massive, mind-bending pillars. First up, the Shanghai Tower. This thing is enormous, the second tallest building on the planet, and you can't miss that incredible 120-degree twist. But here's the thing, that twist isn't just to look cool. Shanghai gets hit by typhoons. So using those powerful computer models, the engineers figured out that this exact twist would help the building shed the wind. It actually reduces the wind load by 24%. That's huge. It meant they could use way less steel, which saved a ton of money and made the whole project feasible. Okay, next, check out the Pearl River Tower. This isn't just a building. It's practically a living machine. You see those huge holes in the side? They're not just for show. They're actually wind tunnels. The whole shape of the building is designed to funnel wind right through those openings. And inside, there are giant turbines. So the building literally generates its own electricity from the wind. It was one of the very first skyscrapers designed to be a power plant. And then you have this thing, the CCTV headquarters in Beijing. It looks like it just shouldn't be standing, right? It's basically a continuous loop that defies gravity. You have these two towers leaning towards each other with this massive section connecting them way up in the air. And the craziest part of the story? When they had to connect the two top pieces, they had a 30-minute window right at dawn when the temperature was perfect. Because if the steel was too hot or too cold, it would have expanded just enough to make the whole thing fail. Can you imagine the stress? Just when you think you've seen it all, someone decides to build a skyscraper horizontally. I'm not kidding. This is Chongqing Raffles City. That thing connecting the tops of the towers. That's not a bridge. It's a 300-meter-long building weighing 12,000 tons, just lying on its side up there. It has gardens and swimming pools inside. So how does it not just collapse in an earthquake? Well, it sits on these enormous bearings. Think of them like giant shock absorbers. So when the earth shakes, the sky bridge can actually slide around a bit, independent of the towers underneath. Absolutely brilliant. All right, for our last one, we're flipping the whole idea of a skyscraper on its head. Instead of building up, this one goes down. This is the Shimao Wonderland Hotel, the world's first earth scraper. They found an old abandoned quarry, 88 meters deep, and just built a hotel right down the cliff face. I mean, think of the challenges. All of engineering is about fighting gravity to go up. They basically had to invent a whole new type of construction just to pull this off. And look, these buildings aren't just one-off freak shows. As one expert said, every single solution developed in these towers is now changing how engineers worldwide approach super tall design. Basically, all the clever tricks they learned about handling wind or surviving earthquakes, that's all becoming standard practice now. These buildings didn't just break records, they literally changed the game for everyone. So, what does this all add up to? Well, it's pretty clear we're in a completely new era of building. You've got basically infinite computing power to design and test anything you can dream up, and you've got robots that can build it with perfect precision. Put those two together, and all the old rules, all the physical limits we thought were set in stone, they're just gone. It turns out the biggest limits were the ones we put on ourselves. Now, it really feels like the only thing holding us back is our own imagination. You know, in the end, this whole revolution isn't just about making taller buildings or making them faster. It's about fundamentally redefining what is even possible. So it leaves you with this one kind of mind-blowing thought. We've just seen what robots and AI can do with a single skyscraper. What happens when we scale this up? What happens when they start building our cities? What about our first homes on Mars? What happens when they start building our worlds?